My name is Matt Walker, and today we're going to be doing a SimpliPhi Elite IQ installer training. Today we're going to be talking about DC wiring and boss cabinets. So I'm really excited to give you guys my take on how to best wire lithium batteries, best practices, best products, conductor sizing, overcurrent protection, just battery wiring methods in general as it applies to DC systems. So stick around and please pop your questions into the Q&A section. Don't be afraid. I will cover everything during the presentation. If not, I'll cover it at the very end and just leave time for any questions at the end as well. Awesome. So I'm going to start with a brief background about our company in case you have not heard of us before. I'll be real quick with these slides in case you've heard them already. We were founded in 2010 as OES Energy. Some of our batteries are already out in the field, outliving their 10-year warranty. We have been using lithium iron phosphate right from the start. We have dipped our toes into mobile as well as residential, military, and even emergency response applications. So we've been around the block in some of the more intense applications, and now we're focusing on expanding our product line to kind of, in case what installers and customers are needing nowadays. We want to make sure we listen to the market and understand what you guys need from us. As of 2015 and 16, we have relaunched as SimpliPhi Power. We are now ramping up manufacturing at our Ventura County, California location, and we are now part of Briggs & Stratton. As I mentioned, we use only lithium iron phosphate chemistry due to the safety, longevity, and performance of the chemistry. And we use only cylindrical form factor as well. So that is kind of the building block for our battery. Cylindrical are, in our mind, the safest, best performing, longest type of cell. It can handle, a lot of pressure buildup inside of there. It's very difficult to force it into thermal runaway, as opposed to a pouch cell, for example, is a bit more flexible, a bit more prone to puncture or swelling. And a prismatic cell is fine as well. We just simply found a better lifespan and performance out of cylindrical cells. So all of our products are UL listed where applicable. This doesn't necessarily apply to everything we make, but it definitely applies to most of the products that you would install in your house. So our Phi batteries are UL listed at 1973. And then our access units and boss cabinets are past 9540 certification in many configurations. What this allows you to do is streamline permitting. So if you're an installer, the place you probably hate spending the most time is behind your desk. We are trying to cut down on that by making permitting as simple as possible for you. We've got a 9540A report as well, which is needed only for some jurisdictions, and that's essentially a fire test protocol. So really the UL is a third party that creates a safety test and performs it on our batteries and certifies that they're safe. Not only does this give you peace of mind as the homeowner or installer, but it gives the jurisdiction peace of mind when they're permitting and inspecting the system. Awesome, so let's jump into some wiring methods. First, I wanted to show an incorrect example, so do not follow this style of wiring. This is one of the main issues we see from time to time. This is called daisy chain style wiring. It's very popular with lead acid batteries. And there's no issue with doing this with lead acid batteries, but there is a problem with lithium. So let's look at what happens in this scenario. You've got 5 batteries daisy chained. Your inverter and charge controller, it's all in one box here, is putting out, let's say, 50 amps and 56 volts. What's going to happen here is under high currents, it's normal to see maybe a half a volt drop between the inverter and the battery bank. So let's say you've got 55.5 volts at the first battery. Normal. The problem occurs where down the line, if you're still pushing high currents in these wires, there's a cascading voltage drop across them to where across the whole battery bank, you may have a 1 volt drop or so. This is going to create an issue. So the issue occurs firstly because the batteries are going to share current unevenly. So this first battery in the bank closest to the inverter is going to be putting out the most current. It's going to be working the hardest. When you reverse the roles and discharging occurs, the same thing's going to happen. This first battery in the bank, it's going to work the hardest, and over time, it's going to wear out faster. So this is an important thing to avoid. Avoid daisy chain wiring. Here's another reason. So you might be looking at 54.5 and 55.5 on the two sides of the bank and thinking that seems like a problem as well. It is. A 1 volt difference in a lead acid battery might mean about 10, 12, 15% state of charge difference. That is not a huge problem. It's a small problem, if any. Whereas, a lead acid battery, a 1 volt difference in state of charge, let's look at between 52 and 51, that's about 60% state of charge difference. That's a huge problem. So going back here, if you've got a lead acid battery and you've got 10% difference or so in state of charge across the whole bank, small problem. Lithium bank, 60% state of charge difference across the whole bank. That's a big problem. So this is not good, not a good wiring style, and it can void your warranty as it will cause the batteries to wear unevenly and become imbalanced over time. Now let's talk about the right way to do it. So I don't want to just harp on issues. This is the right way to do it. So using individual cables for each battery, going to a common combiner point. So those individual cables for each battery are the same gauge, same length wire for each battery. So the best way to do this is you measure. You say, okay, the farthest battery from the combiner is 8 feet. I'm going to make all the cables 8 feet, and maybe you coil the excess cable on the batteries that are closer to that combiner. Maybe you've got some wire gutters you can throw on there, even better. But this allows the batteries to share current evenly, and you can check this with your voltmeter. Each branch or each battery will have probably within 1/10 to a half of an amp of the same current here, as you've balanced them very well. And they'll all see the same voltage drop. So yeah, they might have a half volt drop between the inverter here and the combiner block, but they'll all see that same half volt drop, which is normal, instead of some of them seeing a 1 volt drop and some of them seeing a half volt drop. So this is the best way to wire lithium batteries, and it's really required for your warranty, not only with us, but with most other companies as well. Now, you may find this method time-consuming if you've got a bank of 20, 30, 40, 100 batteries. So let's look at some other options. You can also bus groups of batteries. This is a little bit more complex. So each group of batteries, you want to share the same amount of current, right? You want them to have the same number of batteries. If you've got one group of batteries that's 10 and one group that's 5, they're going to be a little bit imbalanced and see a different voltage drop between them and the inverter. So if possible, make sure the same number of batteries are in each group. Now, if this is not possible at all, you've got to use a prime number of batteries. Let's say you've got to use 13 batteries. The best way to do this is either to use cables or to simply contact us and we can develop a solution for you. So making sure that we use maybe a different length wire for one group of batteries that has less batteries. You want to make sure that voltage drop is the same. So each battery needs to see the same voltage drop between its terminals and the inverter. Now, another important thing to keep in mind when you're using bus bars directly on the terminals is that they need to be rated to handle the max current you're going to use. I'm not talking about surge current. I'm talking about if you've got, 30 amps continuous per battery, then you need your bus bar to be able to handle that 30 amps per battery. So in this scenario, we've got 10 batteries on a bus bar that, let's say the load was 20 amps per battery in this scenario. You need that bus bar to be able to handle 200 amps. We'll talk a little bit more about conductor sizing as we go on, but this is important. You don't want to use an undersized bus bar, or you'll be dealing with either overheating or, as I mentioned, that voltage drop and unequal sharing of current. So another thing that may be coming up here is you may be thinking, why can I use bus bars directly on the terminals, but I can't use 4-aught jumper cables to daisy chain the batteries? I hear your concern. The issue is that when you're using a jumper cable, it's a manufactured connection there between the copper and the lug. That's some resistance. And then the lug and the other battery lug going to the next battery, that's some additional resistance. Even on that nice flat connection there, there's a bit of added resistance there. Much more so than if you have a big thick bus bar where current, traveling from this battery all the way to the end of the chain has a clear path with no interruptions in that thick piece of copper. There's very, very little resistance from the start to the end of this bus bar, even as opposed to those 4-aught jumpers. So this is why you need to use bus bars direct to terminals instead of jumper cables. All those little connections that need to be made really add up under high currents. All these wiring problems are exacerbated by high currents, high charging and high discharging currents. And I will say I have tested this myself. So I've taken our 3 battery bus bar kits on groups of 3 batteries, charged them at their max load, 37.5 amps per battery, and checked. They're all sharing exactly the same amount of current per group of 3 batteries, and there's the same voltage drop between each group of 3 and the inverter. So this does hold true across large systems and small systems alike. Another thing to keep in mind, though, if you are using these direct-to-terminal bus bars, you still will have to combine any multiples of groups. So if you've got, let's say, 3 groups of 10 batteries, you still have to combine those groups onto some sort of bus bar or terminal block again. That is one thing to keep in mind. And then, so in this example, they've got these 3 jumpers on the left. These jumpers go from this directed terminal bus bar all the way to a common bus bar or combiner. And these jumpers may need overcurrent protection. Now I say that because most of the time your load is not the size of the battery breakers. So let's look at this example, 80 amp battery breakers on each battery. This bus bar does look like it's rated to handle 800 amps. But these cables, I'm going to guess that they're not, right? So if they're not rated to handle 800 amps, your inspector might require some sort of overcurrent protection on there, since these batteries technically could provide 800 amps. Just a second here. All right, so I mentioned our 3 battery and 2 battery bus bar kits. These are what they look like. They go direct to terminal. They come with the holes already spaced perfectly, so you just pop them on the battery and then tighten down the lugs. Basically, these are available for 2 or 3 batteries. If you've got a big project, we may be able to make something for 4 batteries as well. Another option for combining batteries, though, if these 2 and 3 battery bus bar kits are not enough for you, let's say you're combining a system of 100 batteries. You probably want something that's going to be able to ease your wiring a little bit more, so you can put more batteries in each group and use less individual cables. In that case, you could try contacting Storm Power Components. So I'm giving specifics here. Storm Power Components is a company that manufactures custom bus bars. We know they've worked with our stuff before. We can send them the dimensions of our batteries so they can make direct-to-terminal bus bars for you, or you can even manufacture them yourself. If you've got a drill press or CNC, something along those lines, you can definitely take care of this. For smaller systems, I like the Midnight 250 amp combiner. So the SKU is right here, MNLBC-W250. This is the W250. It's got a 250 amp disconnect in there. It's also got the ability to take 10 battery strings into its input, positive and negative terminals, and then have, one output cable going to your inverter or charge controller, or both, hopefully. Now, another option, since 250 amps may be too small for you, is Midnight has a 1000 amp combiner box. Now, this thing is massive. It's the size of my entire upper body, and it's not lightweight either, but it handles 1000 amps, and it's got a lot of room for you to work and tie your cables in there. A smaller, more compact 1000 amp solution is the Victron Energy Lynx system. So this is what you see in the bottom right-hand corner. The power in is what I'm looking at right now. That is simply a 1000 amp bus bar, and you see these red and black kind of terminals on the ends. That allows you to actually take 2 Victron power ins and pop them together. So you can make, instead of, this has 4 connections inside of it, instead of that you can add 4 more and 4 more, as many as you need in multiples of 4. This is growing in popularity, especially, of course, as Victron does amongst mobile customers. Another option is the Lynx distributor, which is the same thing as the power in, but it actually has individual fuses. So what I like to do is use the power in on the battery side, since they already have breakers, and then the distributor on the load side, so I can add fuses to my loads. You can even put a shunt in the middle of this system, so the power in holds the batteries, and then there's a shunt as your battery monitor, and then there's the distributor to your loads and chargers. So this is a great system to add in a battery monitor easily. A probably more simple option is even just a standard bus bar. So in the lower left corner, you see the Blue Sea Systems. It's called the Power Bar. Now they have power bars rated from 100 to 1000 amps. The one you're looking at right there is 600 amps. You see that thick, very, very thick tin-plated metal that is conducting 600 amps without a problem. Now lastly, something most of you don't even know about yet is our Boss Cabinet combiners. So let's see, it's coming up here in a bit, but we actually make Boss cabinets that house 6 to 12 batteries. We will chat about this in just a minute. And we can mount a 1000 or 2000 amp bus bar inside of those. We do positive and negative, so it's one combiner, it's outdoor rated, and the 1000 amp version is even UL listed. These are NEMA 3R rated enclosures, super safe. It's very heavy, it's not a small enclosure. Um, it is definitely a go-to for larger systems. So if you've got something over 1000 amps, you're not going to be able to find 2000 amps off the shelf anywhere else that I have seen. So it is definitely a good option for these bigger systems. All right. I don't see any questions coming across, so I must be doing a great job at explaining things. Either that or you guys are asleep. So let's talk about wiring washer placement. So washers are going to be very important here. You don't want to block the connection between your current carrying cable or bus bar and the battery lug, or excuse me, the battery terminal. The bus bar or battery cable lug should go in direct contact with that battery terminal, nothing underneath of it. The washer, lock washer, and cable, lock washer, and nut can go on top in that order. They do not go underneath. So never put a washer in between your current carrying material and your battery terminal. It's just going to add resistance and add heat and add a voltage drop and reduce efficiency. So talking about voltage drops, heat, and reduced efficiency, let's talk about conductor sizing in a little more detail. This is a highly debated topic, so bear with me here. All right, so overview of the steps to designing the, system wiring sizes and components you're going to use. First, something that some people do wrong, or I think they maybe go overboard on, they simply will look at the battery and say, oh, well, the battery is capable of 80 amps, and I've got 10 batteries, so I need to rate everything at 800 amps. That's a lot of wire, a lot of copper there. You're going to be paying a lot for that wire. Here's what I'd recommend instead. And I've yet to have an inspector or an installer call me and say they had an inspector have an issue with this. So I've been rolling with it. Use the max continuous load and charge amperage combined. So if you've got a total of, 10 kilowatt load, that's your max continuous load. Use that as your size, and then downsize from there. Regardless of how many batteries you have, start with the load. Use that load to determine the max amperage on each battery wire. And I'm not talking about surge here. I generally would recommend sizing for continuous current, as the surge capacity is often built into that wire or bus bar. Next, using that amperage on each wire now, look at the charts for your NEC minimum wire size for that current carrying capacity, and then make sure that matches with what your AHJ wants. This is going to help you pass inspection first and foremost, but also be safe and prevent overheating. Lastly, you're going to check, if that voltage run is across if that wire run is over a certain length and you're worried about a large voltage drop, you're going to want to upsize the wire from there. So you really do not want a inefficient system. So if you've got, going back to the beginning, if you've got a half a volt drop across your inverter to battery at full load, full 56 volt, 37 amps per battery load, that's really normal. That's not that big of a deal. That's like 1% drop. That's what I would shoot for. However, if you've got a 2-volt drop under max load, that's a really inefficient system, and it's not going to even allow the batteries to reach their full state of charge. Your customer's going to be concerned about where their battery capacity is. So, like I said, if there's a 60% drop in state of charge between the top and bottom of the battery bank, that's not an efficient system, and it's not even going to let the batteries reach full state of charge. So let's do an example here. I think this is a little bit vague, and I want to make sure you guys understand this. So let's use this example. You've got one Solarc and you've got 6 batteries. This is a Solarc 12K, a little misleading because the battery load is 9 kilowatts. It's 185 amps total. So a total of 185 amp load or charging capability, and then you're going to split that between all these individual battery cables, right? So you got 6 batteries sharing that load equally. How are we going to size these conductors? First, you note that the max load and charge amperage is 185 amps. You can just look at the Solarc spec sheet and it'll tell you this. Not talking about surge here, this is continuous. Then use the amperage on each battery wire. So if you've got 185 amps and you got 6 batteries, 185 divided by 6 is about 31 amps per battery. Next, you're going to look at the NEC minimum wire size. So let's open this up. This is just a chart that I have found online. And we said that we had 31 amps for the battery wire. So 31 amps is more than 30, so you're going to have to go to 40 amps. That means you can use 8 gauge for the battery wire. Now, going back, we said we had 185 amps for the inverter. That means you're going to use 4 gauge battery wire, inverter to battery wire. Now that's considering a 60 degrees Celsius rise. Your conductor may be rated to handle a 90 degrees Celsius rise. I wouldn't necessarily recommend using that because, like I said, the bigger the wire, the more efficient the system. So I always go with the 60 degree rated conductor, but it depends on your conductor rating. So use what you feel comfortable with. Now just a minute here as I get back to my place. So we've determined the minimum wire size. 8 gauge for the battery wires and 4 gauge for the inverter to battery bank wires. This is the absolute minimum. Remember, now let's say you've got a longer run of inverter to, battery wire. You may need to upsize the run. This is a really helpful chart to look at. This chart is from Blue Sea Systems, and they talk about the voltage drop across a wire. So if you've got a DC circuit and you want to keep the voltage drop under 3%, so let's look at the battery connection here. We said we had 31 amps, so we're going to go to this 40 amp section, and let's say that the positive plus negative length of wire combined is 15 feet. In that case, you're going to need 6 gauge to keep it below a 3% voltage drop. I would even consider upsizing from here because if you've got a 3% voltage drop between your battery bank and combiner, and then another 3% between your combiner and your inverter, that's a total of 6% right there. That's a big loss under full load. I would even consider going larger from here. So let this be your new minimum of 6 gauge, and then even consider upsizing from here. Most of our installers are using 2 to 4 gauge battery wire because they want their system to be extremely efficient. Hope that makes sense to everybody. Going to pop into the question and answer section. 4-aught is not 4-gauge. Correct. So there's two separate things here. 4-aught is 4-0. That's able to handle much more amperage than 4-gauge. So in our installer Dale's area, they're requiring 60 degrees for wire calculations, and some even 45 degrees. So Dale, you can probably host our next webinar on this. That would be really helpful. What if one battery goes bad and now the load is not spread equally over the bank? That's a great question. Luckily, each battery has that 80 amp breaker built in so that there's not a massive cascading effect. You know, that's a really valid point though there. All right, just 1 second here. Apologies, I may have called for 4-gauge instead of 4-aught. The inverter wire for 185 amps, I believe would be 4-aught. Let me just double check here. So yeah, 185 amps, I would use 4-aught, 4-0. Thanks for catching that. All right, let's move along. So this is just showing you that these wires, each the red and black would both have 185 amps flowing through them, while each battery wire would have 31 amps approximately. Now, one of our guests made a good point. If one battery did drop out of the bank for any reason, the rest of these would pick up, the slack and provide that extra current. So it's something to keep in mind. Again, your battery breakers have an 80 amp rating on them. So it's possible that your inspector will say, well, because of this, I'm requiring you to have wire rated to handle 80 amps. That is a possibility, and it's really not a problem. I think an 80 amp rated wire for your battery to inverter connection is probably the best bet anyway. Like I said, more efficient system. Here's another way you could have done that. So let's say you had our access cabinet, or you just wanted to use bus bars. So if you're using bus bars to group 3 batteries together, each group of 3 is going to have 93 amps of that 185 amps running through that wire. So this is a much larger wire, different rating here, and it's less wires for you to run. So this might be an advantage. You might want to check out our 3 battery bus bars. You can order them to include cables. Just another option. There's a million ways to wire a DC battery system. All right, overcurrent protection. This I am sure I'm going to get some comments on. Always a debate here. Just giving you my personal tips, what I like to consider before consulting my inspector or my jurisdiction. First off, remember that not all overcurrent protection is the same. Every type of breaker or fuse is going to have a different trip curve. So they're going to trip faster for a fast blow, slower for a slow blow. Maybe some of them are rated to trip at 120% of their load, and others are rated to trip right at their rating. So it's every form of overcurrent protection, and every brand is built differently and to serve a different purpose. Really, it's there to protect the wire. Overcurrent protection is there to protect the wire more so than the equipment, at least in most cases. One thing to think about is, a 50 amp max current value does not always mean you want a 50 amp fuse or breaker. It depends on that trip curve, really, and it depends on your customer's use of the system. So maybe your customer really wants to make use of that 80 amp surge, and your fuse is a 50 amp fast blow, and it's opening as soon as they try to make use of that 10-minute battery surge. So this is something to keep in mind if you want to utilize the surge or allow your customers to utilize that surge to maybe start a well pump or run a large load for a couple of minutes. Additionally, make sure your DC fuse or breaker is rated to handle the maximum voltage that's going to be present in that circuit. So if 56 volts is your max charging voltage, the breaker or fuse needs to be rated to 56 volts or more. Lastly, only use AC breakers on AC circuits and DC breakers on DC circuits. Same for fuses. So the AC breakers are utilizing this point of zero current in this diagram here to extinguish the arc present when you open that circuit under a load. Whereas a DC system does not have a point of zero current. The current's always flowing in that one direction. Therefore, they have to use a magnet or other mechanism to extinguish that arc so it doesn't cause a fire. So Ryan at Midnight Solar has made this awesome video linked here that we won't watch now, but I'm going to leave for you the link in the slides. This is a very cool video where he explains his tips to DC breakers at Midnight Solar, and then he even has a follow-up video where he shows you using a DC breaker on a PV array, it combusts as soon as he opens the circuit under a load. So do not use AC overcurrent protection on a DC circuit. I wanted to dive into the trip curves a little more. If you haven't seen these before, I think they're really interesting. So, a 60 amp breaker is not going to, watch, oh, as soon as there's 60 amps, I'm opening the circuit. It's just a thermal device. The two pieces of metal will separate as they get to a certain temperature naturally. So this trip curve is really important to understand. If you've got a 60 amp breaker, it's likely going to be handling about 75 or so amps before it opens. They're not always rated to open right at 60 amps. Some of them are. Some of them are made to open right at 100% of their rating. And you've got, just another example, a fuse. This is not all fuses, but this specific fuse is rated to pop around 140% of its rated current. So this would be, closer to 80 to 85 amps of where this fuse would open circuit, and then 85 amps would have to be present for 10 to 20 seconds for this fuse to even begin to open. So this is maybe a better bet for 80 amps of protection, allowing you to use that battery surge for a couple of seconds. These are all from Blue Sea Systems, by the way. They have, trip curves for all their products, which is really nice to see. All right, and one thing to point out is that if you don't feel like dealing with overcurrent protection, our batteries have a built-in breaker already on them. So if you want to, simply just rate your wire to the surge of the battery. Most of them are 80 to 100 amps, depending on the model. Then you can just do that, and it simplifies everything for you, so you don't have to think about overcurrent protection, and the wire sizing is made a little easier on you. An overview of our products and how they relate to this. So most importantly, I wanted to talk about our Boss cabinets. Let me just skip along. So our Boss cabinets are rated to hold 6 to 12 batteries. They are made with powder-coated steel, NEMA 3R rated, they're outdoor ready. They have passed 9540 and they have a 9540A report ready and completed. They've got a 650 amp 5-point terminal block built into each cabinet. This comes with 3/8 inch lugs, as do the batteries. So if you're purchasing wires, make sure they have 3/8 lugs on both ends. Excuse me here. The 2 or 3 battery busbar kits are sold separately, but highly recommended with our Boss and Access cabinets. This is going to make your wiring so much easier, allow you to combine the batteries into groups of 3, so you have no more than 4 wires landing here, incoming from the batteries, and then you have 1 terminal left to go out to the inverter. We also offer this Boss 6 cabinet as a combiner. So I mentioned this earlier, we can actually remove the battery shelves and terminal blocks and mount a 2000 amp or 1000 amp bus bar, both positive and negative, inside of this box for you. This is, again, still an outdoor rated product, even as a combiner. And it's got knockouts for easy conduit pairing. So this is a really good option, I would say, mostly for systems that are above 1000 amps, as we got that 2000 amp rated, or systems that your inspector is going to make sure the whole system is 9540. We've got this in our 9540 listing, so it is good to go there. Going to streamline your permitting. So let's talk about the batteries as well. Going back here, our batteries are a simple parallel connection. Our products are not made to be put in series, so remember those wiring styles we talked about. It's a 3/8 inch terminal post. This is a very scalable solution, so it's a simple drop-in lead acid replacement. You can parallel as many of these as you want. The Phi battery is, it doesn't have communications, so it operates just like a lead acid battery. You can program whatever inverter or charge controller you have to be compatible with the battery, as long as it's able to reach our specified set points. It comes with an integrated BMS in addition to the circuit breaker. The battery management system is going to keep the cells balanced and provide a little bit of additional protection. Now, same size, same dimensions, same amount of kilowatt hours and charge and discharge power is our SimpliPhi battery, which now has communications built in. This is able to talk to the Solark or Sunny Island inverter, communicate intelligently, and explain what the battery's needs are at any point in time. So for example, let's say you throw one battery on a large inverter, way too large. Maybe you got a Solark 12K with one SimpliPhi battery, not a good pair. But this SimpliPhi battery is going to communicate to the Solark and tell, hey, do not discharge too quickly. I can only handle 1.9 kilowatts. And that Solark is going to pick up on that signal and reduce the charge and discharge rate. It's also going to provide the user with a high level of accuracy in terms of the readings for state of charge and voltage and charge and discharge. This is something the user can see on the inverter's LCD screen, as well as the online monitoring platform like PowerView. You're limited to 75, I know it says 40, but we've updated this to 75 battery modules in parallel. This is because the communications cable is limited in length. And here's what they look like stacked inside of our Boss cabinets. These are the Phi batteries. Wanted to highlight our IQ installer Sun King Inc. of Hawaii. They are installing batteries on multiple islands there, and this is just such a great use of our Boss cabinets underneath some solar panels. So this is an outdoor space, and so the Boss cabinets made a good fit here. Looks beautiful. Great work, guys. If you're in Hawaii and you need somebody to install batteries, Sun King Inc. can be reached at sunkinghawaii.com. Wrapping up here, we've got some resources for you. So I linked to a few things during this presentation. One is that many of my images came from our wiring guide. So on our website, we do have installation manuals and integration guides and wiring guides that show you approved wiring methods, best practices, example calculations, all that stuff that I just did. It's all in our wiring guide. So make sure you print that out and take that to site with you if that's going to be helpful. The DC wire gauge chart that I referenced from Blue Sea is available here. That's really nice, especially if you've got a longer run. It saves you a lot of time in hand calculating these wire gauges that you need. And you definitely need to already have this. I'm hoping all of you already have access to this if you're installing our batteries, but NEC charts as far as ampacity ratings for different wires. So make sure you're using that, and that is the most important absolute minimum wire sizes to be using for safety reasons and inspection reasons. Lastly, wanted to touch on our installer program. A lot of new developments here. If you are already installing our batteries, why haven't you applied yet? Make sure you go to our website and apply. We can give you money back in your pocket. I'm not talking about a credit towards future purchases. We are simply paying out IQ installers $25 per battery they install. It's a simple process. You register the warranty of the battery to get this cash back. In addition, we are doing that to say thank you, but we also want to keep you busy. We want to send you direct leads by putting you on this map. This map is what we use and what we direct customers to send them to the nearest installer near them. I also work very closely with our marketing team to get your photos in our social media and newsletter, even on our website. So we have a photo contest where we really want you to send us our photos so we can blast them out for you and get you more promotion. We will even pay you $250 if you win the monthly photo contest, rolling entries. So if you don't win one month, you may win the next month. So send in your photos to me and I'll get you squared away. You can apply here for the IQ program. So make sure to do this again if you're already installing our batteries. You're wasting your time not to be a part of the IQ program. You don't need to sign up to start installing. You can begin installing right away and then become an IQ installer once you're confident with the product and happy with the communication with us. Thank you for coming. I want to leave some time for Q&A. We've still got a few minutes here. All right. Can you mount the batteries onto the concrete floor? Does code require the battery to be inside an enclosure? And if so, which code section? All right, so you can, according to us, leave your batteries on the floor. And they don't need to be in an enclosure if they're indoors. If they're in, temperature controlled environment, not going to be exposed to moisture or harsh, sunlight, things like that, you can leave them on the floor, no problem. The batteries alone are not outdoor rated, so keep that in mind. Now going back to the code, many jurisdictions are going to call for 9540 nowadays. So if they are calling for a UL 9540 certified system, that will need to be in a cabinet, in some type of enclosure. Now, our Boss cabinets do meet that requirement. However, you don't need it according to us. Remember, we don't care if your batteries are in an enclosure. Check with your AHJ. Very good presentation. Thank you. Thank you so much, Daniel. I really appreciate it. Glad that I was able to help you out today. What's your experience with stacking two ring terminals and bolting them onto the bus bar of the inverter? Two ring. Okay, so you're talking about taking two cable lugs and stacking them on top of each other, on the inverter. Not a good idea, I would say in general. You can get away with it sometimes if it's a very large cable lug and they're able to really make a nice, clean, flat connection. But I don't think it's a good idea. There is some increased resistance there as opposed to mounting it on a big beefy bus bar. So if it's ring terminals, small Home Depot ring terminals, definitely not. Big beefy 4-aught battery cable lugs, okay, yeah, maybe you can stack two of those. So kind of just depends. It's all situational. Hopefully that answers your question a little bit. Awesome. Well, I really appreciate everybody coming. We will automatically send out the recording to you and the slides if needed. So give us a email if you need anything. But again, those recording will be coming automatically in the next 24 hours or so. So email us at training@simpliphipower.com. If you need help with signing up for our installer program, any questions, designing a system, any follow-ups to this presentation, feel free to email me. And aside from that, thank you for coming and have a great day.